Hello, my fellow mathematicians. This is Ms. Backfish, and I am here to show you how to use Desmos to find and also to use a quadratic regression equation. Okay, so what's a quadratic regression equation? You know at this point what a quadratic equation is, probably, if you're watching this video. A quadratic regression equation is all about coming up with an equation that fits some data that we've been given, that fits some specific points. We don't know what the equation is starting out. We just know some data. We know some things, some information that seems to fit a quadratic pattern, and we're trying to use that. So here is some data that I'm going to use that I just pilfered off the internet. There we go. I centered it a bit for you. And what this is this is a comparison. If you see the X values there, those are the speed that a car is traveling. And the Y values represent the gas mileage the car gets. It's actually interesting that this is something I thought you might be interested in as a driver. There is a sweet spot for gas mileage, and it is right around, if you notice, some of the highest numbers are right around the low 50s. This is actually one of the reasons the first speed limit, highway speed limit ever put into place was 55, is because of gas consumption reasons. So this is basically a quadratic situation, and the reason I know it's quadratic, and I don't have to know that starting out, by the way, but I can tell this is quadratic because it starts out here in the low 20s, and then it goes up to the low 30s, and then it looks like it's going back down. Quadratic equations, remember, their graph is a parabola. A parabola might do this. It's not the prettiest parabola ever. Or it might do this, but it does start going in one direction and then turn around and go the opposite way. So that's why I think this data is probably quadratic. But let's see. First thing I've decided to do here is I'm just going to cut that data down a little bit. I'm just going to use these 7 values. And you notice I wasn't even careful to equally space my x's. A lot of times when we collect data, it's not going to be nicely spaced. So I went ahead and just jumped around a little bit. But I just chose 7 of the values from that chart because there were 13 values there, and that's quite a lot to type in. So I took roughly half the values. And then we're going to go to Desmos and open it up. Okay, so when I talk about going to Desmos and opening it up, I'm talking about desmos.com and opening up a graphing calculator window. And when I do that, I'm going to adjust this window a little bit so you can see all of it. Okay, when I do that, I have the area over here on the left where I could type in an equation. So if I wanted to graph a line, I could type in y equals, let's see, 3x plus 5. And there would graph my line, y equals 3x plus 5. So that's where I'm going to put anything I want to input, and I can open up additional entries here. If I want to change my graph, the graph settings are over here on the upper right. Okay, it looks like a little wrench. So if I want to change my graph in a specific way, now I can just zoom in and zoom out like this. And if I've zoomed in or I've zoomed out and I want to go back to the standard viewing window, that's down here, little home, I go home. Okay, so usually we're going to have to change this window to make it fit what we're looking for. So in order to put it in a table of values, which is what I had here, this is what I'm using, and I'm just going to move these over here and see if I can leave it up. I need to take this plus sign, click on it, it's not going to stay up, sorry, and this will give me a table. Okay, so I've narrowed my window so that you can see a little better. We can see both things at the same time. But one thing I want you to notice is the table starts out for the x and y, it calls them x1 and y1. That's in case if I did another table, it would call it x2 and y2. And that will become important to us potentially. So I'm just going to input this data, these 7 data points, x's and y's, and you can use the tab button to move between from one entry to the next, or from the left side to the right side, from the x values to the y values. and there it is. Okay. Now, I've put in these points. These are all representative of points. Like each one of these is an X and a Y, and that makes 1 point. But you notice I don't see any points on my graph. Well, that's because I'm looking in the wrong place. This is where we have to think about the window. And this is something sometimes you have to deal with on a graphing calculator as well. If you hear a dog barking outside your house and you look out the kitchen window and you don't see it, does that mean there's no dog? Or maybe it's on the side of the house. Or maybe it's behind a tree. You know, maybe it's that you can't see it out that particular window. Same thing goes here. So I'm not going to see X values between 15 and 75 if I'm looking between -10 and +10. And here the Y values are between 22 and 20 and, well, 30, really. And this doesn't go up any higher than 7. So we could just zoom out a bunch. That's one option. And if you do that, you'll start to see them. And you can also see that it does kind of look like it curves, like we're kind of expecting it to do because we think that this particular data is quadratic. Another option, though, that can make it a little bit nicer for you is to go ahead into the graph settings and pick some very specific X values and Y values based on the ones that you have. So I would look at my X's over here and I would say, well, it looks like the smallest X is about 15 and the biggest is about 75. So I'm going to pick a number smaller than my smallest X, but not by a lot, like maybe 10, and a number bigger than my biggest X, maybe 80. And I'm going to say on the X-axis, I want it to go from 10 to 80. All right, and then on the Y-axis, I can do the same thing. It looks like the smallest Y is 22. So how about 20 as the bottom? And then the biggest Y is around 30. So let's go with maybe 35 at the top. That'll work. You can play with those numbers, and you don't have to have the same ones I do. I'm just giving you some suggestions. And now you can see it's nicely spaced out in our viewing window. Okay, now you can tell that this looks kind of like a parabola, but it's not going to be exact. And usually with real-world data, it's not going to be exact. That's why we're doing what's called a regression equation. So a regression equation is about fitting the best way that we can fit the data to a mathematical model. You have probably done this with a line, a linear regression. And when you do a linear regression equation or a line of best fit, you're coming up with a line that seems to go basically through your points. Here's a quick example that might look familiar. That's a line of best fit, a linear equation that goes through some data points. So that's why it's okay that my data is not going to be exactly quadratic, because I'm just trying to come up with an equation that models this in a quadratic way. By the way, as I was playing with this, I realized there's another faster way to get a good window here, although it's really not a bad idea to know how to do it this way, just to know how to think about what are my X values in terms of what's the lowest they would be and the highest they would be. But another way to do it is see this little zoom fit. If I hit this, boom, it's going to zoom right to a window that fits your data well. All right, so now what? How am I going to come up with an equation that models this? And that's where I'm going to type in a version of the standard form equation for a quadratic equation. What do I mean by that? Well, when we work with quadratic equations, we frequently like to put it in this standard form. A times our x squared plus b times our x plus c. The a and the b and the c are the same coefficients, which means basically the number in front of a variable is those coefficients, and this is really the constant, not a coefficient, c is, that we use for quadratic formula. So we're basically typing this in, but this is Desmos. It needs us to type it in a certain way. Anytime you're working with a computer program, it very often has its own way of doing things. So I'm going to type that in right here. But I'm going to type it. Notice it doesn't say x and y up here. I have to use this y sub 1 and this x sub 1. So I'm still going to be typing that, but I'm going to type y sub 1. And the easy way to do that is just to type y, and then when I type 1 right after it, it goes down there in the subscript. Now the next thing I need is I need this little squiggly thing. It looks like this. And if you're using a computer, you might be able to find it on your keyboard at the top. That might actually be the easiest place to find this. But there is another good place to find it. down here at the bottom of your screen in Desmos, you see this keyboard. So go ahead and click on the keypad. And then we have an option here that says ABC that takes us to more like a typewriter keypad. So click on that, and then you'll see that same symbol on the bottom row. Right here on the bottom row, you see that symbol. So I could click, ooh, it's going to give me 2 when I've already got one. I'm not going to do that. So I'll remove the one I typed from my regular keyboard and add it from here. So no equal sign, no dash. It has to be that squiggly, little squiggle. All right, and now I'm going to press, this is ax squared plus bx plus c. In other words, this. But I'm going to type it the way Desmos wants it. The a, the b, the c, those are fine, but for the x's, I'm going to have to put x sub 1. Okay, so a, x, and then I just type 1. It's going to make it a subscript, but now I have to go square this. So the easiest way to do that is same keyboard down here, but this time I want the 1, 2, 3 keyboard. And notice right here, this button right here, squared. Okay, so A, don't forget this X has to have the subscript 1 and it has to have the 2, the squared. B plus BX plus C. Okay, let's see. It's not happy with what I typed, so something is wrong. Look what's wrong. I didn't put a subscript 1 on that X. So if it's not working for you, chances are very good you did not type something correctly. Now, boom, there is my parabola. That's my quadratic equation graphed. Isn't that beautiful? Now, one of the things that you can, if yours did not come up, one of the things you need to look for is back up here in your table of values. If you already had another table and then you opened a new table, it would call these x2 and y2. And then in your equation, you would also have to say x2 and y2, x sub 2. That's the subscript, x sub 2 and y sub 2. So you would have a 2 in the subscript here and the 2 for the squared part. All right, the easier way is just to always close out everything before opening a new table. Okay, so here's my parabola. And what about the equation? I still don't know. I'm looking for writing an actual equation in this form. I want to be able to write it on my paper. So look over here where it says parameters. That's my A and my B and my C. Now you're going to want to look and see what you're asked to round to. But for me, let's suppose I was asked to round this to the nearest hundredth. If I'm asked to round that to the nearest hundredth, that would be negative 0.01. You can have the 0 up front too. But what if I'm asked to round to the nearest tenth? Then it's just zeros. I don't want just zeros in front of my x squared because that implies there is no x squared, and then it's not quadratic. So I would go at least to where I get to a number. Okay, this is kind of like in science you study significant digits. So I would go at least negative, and that's 0.008 x squared plus b is 0.749. I'm going to make that, let's go with 0.75. I like to do hundredths if I'm not trying to get to another number like this. And then c is 13.157, so that would be 13.16 if I'm going to the hundredths place. And hundredths is not a bad thing to round to if you're unsure. Very often, though, make sure you read the problem. The problem will tell you what to round to. And if it's 0 when you round, I would take it a little bit further out so that you get something other than 0 here. So this is my quadratic equation. And now what I can do with that is if you ask me about different x values, I can plug in, that looks like a subscript, sorry, this is on the same level. I can plug in that x value, same x both places, and figure out my y value. What do I mean by that? Well, remember this was real world data, so this was speed versus mileage. So I can use this quadratic equation now to come up with some information about various mileages, the mileage I might expect to get at a different speed. Now, actually, technically, I didn't use that value, did I? I used my other table that had fewer values. But let's go back to my table. let's suppose that you wanted to know what would my mileage be, what mileage would my car get if I was going 85? Or what mileage would my car be getting if I was going 5 miles per hour? Or 100 miles per hour? Something much smaller than this data, or just, it doesn't have to be much smaller, just smaller or larger than the scope of the numbers that we looked at, okay? That's called extrapolation. We use extrapolation a lot. Businesses use extrapolation a lot. If they figure out, for instance, that if we make, 100 items of our product, then we end up making, $2.5 million of profit, okay? So then what would the profit be if I made 300 items of the profit, items of product? Or what if I made 500 items? That's extrapolation, going outside of the numbers that you do know something about, going beyond them, either below or above, less than them or greater than. That's extrapolation. Interpolation is if I wanted to know what is the mileage when I'm going 32 miles per hour? What is the mileage when I'm going 55 miles per hour? In other words, values, 32 would be in between here, 55 would be in between here. So values that are somewhere within the scope of the data that I've been using. Okay, they're in between these numbers. That would be interpolation. Either way, it's about making predictions using this equation over here that you came up with. So let's try to do that a little bit. Let's suppose that I give you a specific x and I asked you to find the y for that x. Let's go back to the one I mentioned. What about 32 miles an hour? The easy way to do this in Desmos, and you could absolutely just plug into the equation. So you could come back to this equation that we came up with and you could say, okay, when x, which is my speed, is 32 miles per hour, what is y? And you would plug in by putting, excuse me, there's a decimal there, putting a 32 every place you see an x. So you could do it that way, but I'm going to call that the long way because we have Desmos open right in front of us. And another way to plug in an x value is basically to go on this equation or on this graph and say, I'm going to open a new equation over here or a new input. And I'm going to say, what about x equals 32? That's a vertical line. X equals lines are always vertical lines. And if I want to know what the y value is when x equals 32, look at where it hits my parabola. It's right here. If I'm going 32 miles an hour, I expect my gas mileage to be 28.756 miles per gallon. If you wanted to know, let's see, what was another one I mentioned? 55. Type in x equals 55. And then go on the graph to see where 55 meets the parabola. And you'll see the y value that goes with 55. So this says when my gas mileage is 55, when my speed is 55 miles per hour, I'd expect my gas mileage to be 29.621 miles per gallon. Okay, so those were values that were between some of these numbers we've used, so that's interpolation. Let's do some extrapolation. How about if I said, how about bigger than 75? How about 80, when x is 80? All right. Well, I can come over here, and it looks like my gas mileage has gone down. When my speed is 80, my gas mileage is only 20.745 miles per gallon. Okay. Now, you can go up high. Now, this is a model, so theoretically over here, let's see, it looks like maybe 106. When you're going 106 miles per hour, is your gas mileage really zero? No, it's not really zero. It's a model. So this just is able to give us some ideas of what it would be. But let me point out that 106 is much bigger than the biggest value here. The farther you get away from the numbers that were actually used to come up with the model, then the less reliable the model is going to be. So interpolation, using it to find values within the numbers between 15 and 75, is going to be a little more accurate with this model than extrapolation, especially, if I use 80, okay, that's pretty close to this, but when I'm talking about 100 miles an hour, that's pretty far off from the data that we were actually putting in. And so I would not expect it to be as accurate at that point. I hope this has helped. Actually, I'm sorry, that's if I have to plug in X. Let me point out that you could also be asked to plug in Y. You could be asked to find out when is the gas mileage equal to 28 miles per gallon. Remember, this was the gas mileage. The Y was the gas mileage. The X was the speed. Okay, so if you're asked when or at what speed is your mileage this, that's plugging in a value for Y. So I'm just going to make a Y equals line. So I'm going to do Y equals, and these are equals, these are equations, Y equals 28. This tells me that I get 28 miles per gallon. This is the gas mileage when I'm going 28.98 miles per hour, or when I'm going 62.6 miles per hour. I get the same gas mileage both places. So a question might ask you, what is the lowest speed at which you get 28 miles per hour? 28 miles per gallon. That would be this one. What is the highest speed at which you get 28 miles per gallon? That would be this one. So you just have to figure out, based on the question, am I being asked about or given an X? Like, which one am I being given and which one am I being asked to find? Which am I getting an X and asked for a Y, or getting a Y and asking for an X? And then you just plug in whichever one you're given and then go look for the point where that intersects our quadratic model. I hope this has helped. See you next time.